There we go. So welcome everybody to our August 2021 SLUG meeting. We are happy to have everybody here. We're super excited to have Ellie and Haley presenting for us today. We maybe want to start with announcements. The first one is we're super sorry about our website. We know that it's having issues. We've gotten some notices, and yes, we're sorry for the 404 errors that you guys are getting. We are in the process of working on it. So as soon as we get that fixed, we'll let you know. We have a temporary site in the meantime that's on a Google site that should have been in the meeting announcement that we sent out. Oh, for those of you who don't know me, some of you may not, I'm newer to the board. My name's Christina McCulloch. I work for Gateway Mapping. So if you don't know me, you probably know some of the others that are in my team. Neil Fraser was on the board here for a while. He's with Gateway Mapping also. So our next meeting was going to be in mid-November, and we are crossing our fingers that COVID cooperates and we can do it in person. So that's our goal, is to shoot for that in person, but we're just going to have to keep an eye on what's going on. The other announcement that we wanted to bring up was for UJIC. Do we have anybody from UJIC in the meeting that wants to jump on for a minute and talk about the conference? If not, I can tell you what I know, but I'm sure that there are some of you there.
My husband is on, Chris McGinty, and he's on the UJIC board, so
all right, Chris,
maybe he could
about it?
say something.
You should be able to unmute yourself.
Maybe he signed in and then
I saw his face for a minute, but not anymore.
Yeah.
Let's see. Well, I can tell you what I know, and then if somebody wants to chime in, they can. The conference is scheduled for October 11th through the 15th down at Bryce Canyon. Registration is currently open, and you have to register by September 10th in order to get a shirt. Apparently they're doing some stylish flannel shirts this year. So there is 2 days of pre-conference and then 3 days of main conference. They reserved a block of rooms at Ruby's Inn that you'll need to reserve on your own. It looks like the deadline to reserve the discounted lodging rate, which is $80 a night, is the September 19th. So if you're planning to go down to UJIC, jump on that. There's going to be, it looks like our traditional mini golf tournament that we do. There's a barbecue dinner show on Thursday night, and then it looks like they're also doing a star party where they're going to go out and do some star watching, which is super fun because in Bryce Canyon, it's, you know, part of that dark sky down there. You can see so many stars, so it's really great. So if you're gonna go to UJIC, get signed up for that. Any other announcements, you guys, that I forgot? All right then.
Hey, I just like to.
Oh, go ahead, Tommy.
I'm on the UJIC board as well, so Chris covers for me all the time, so maybe I can help cover a little bit. So just to add to that, we really are taking COVID-19 serious and into consideration with the Delta variant, and so it continues obviously to uptick, but we are taking some serious precautions, and we just sent out an email explaining what those precautions are. So yeah, just let us know. We're definitely taking it serious and are looking forward to having a good conference in October. So thanks for bringing that up.
Appreciate you jumping in on that.
Christina, this is Chris, did I miss something when I stepped away for 2 seconds?
Yeah, we just did UJIC announcements, but
okay.
Tommy jumped in and just said the one thing I missed. So
awesome. The other thing that I would mention is that we have student scholarship opportunities open.
Great.
And if you or know a student that's in the geospatial arena in Utah, in college or one of the higher ed schools, let them know and send them to the website, because we've got a couple of scholarship opportunities open. We'd love to have a couple of good student helpers.
Awesome. I appreciate that. All right. If there are any students, jump on that. Okay. So we are going to start today with Ellie Leidsman McGinty, so Chris's wife. And she is going to talk about something super technical that I couldn't keep track of the title. So she's going to go ahead and introduce that. So Ellie, it is all yours. Take it away.
Okay, sounds good.
Wait, before you get started, can I say one more thing? If you guys have questions, you are welcome to put them in the chat. I will monitor the chat and I can bring them up so that Ellie can get those answered. She's probably willing to answer specific questions right away, but if you're willing to put them in the chat, we can, I can monitor that as well. So.
Okay, sounds good. So let's get going. So thanks, Adrian, for reaching out to me. I'm actually excited to present some of my work, especially during this difficult time where, you know, there's not a lot of in-person contact. So thanks. So I'm a researcher and a cartographer in the Remote Sensing GIS Laboratory at Utah State University, and I'm also the Utah View State Coordinator under the USGS funded America View program. Today, I will be talking about a few different high resolution land cover mapping projects that I've worked on. So before we delve into the presentation, I would like to quickly introduce the Remote Sensing GIS Laboratory. The Remote Sensing GIS Laboratory, which is more commonly known as RSGS Lab, is located on the USU Logan campus. It is housed within the Quinney College of Natural Resources and directed by Dr. Doug Ramsey. There are currently 3 full-time employees, including myself. The lab hires a number of undergraduate students to work on projects and also hosts international researchers and remote sensing scientists. Since the lab was established in 1990, it has varied in the number of employees, project capacity, and project size. The RSGS Lab partners with a number of different federal and state agencies, such as the Forest Service, BLM, EPA, and the Utah Department of Natural Resources. Through these agency contracts, we work on a variety of projects, ranging from land cover mapping to landscape assessments and to UAS imagery acquisition. Some of the projects that we worked on in the last year include spatial database development and high resolution urban land cover mapping. In this presentation, I will be talking about 3 different projects that I've worked on that use National Agriculture Imagery Program, or NAIP aerial imagery, and high resolution mapping methods. In all 3 projects, I've developed land cover data sets that are being used by various federal and state agencies and city governments in the state of Utah to support improved land management, restoration, and conservation practices. In an effort to set the stage for these high resolution land cover mapping projects, I will provide an overview of the general mapping methods that are used to develop land cover data. While I'm probably talking to a very informed audience when it comes to these methods, I'm choosing to do this to provide you with an understanding as to why certain methods are better for developing high resolution land cover data sets. So as many of you are likely aware, land cover and land use data are generated using a variety of mapping methods. The 3 main approaches to land cover mapping include manual air photo interpretation, pixel-based image classification, and object-based image analysis. While each of these methods have significant value, the latter approach will be discussed in slightly more detail because it provides the foundation for developing high-resolution land cover data sets. The oldest and likely the most accurate mapping method is manual air photo interpretation. Manual air photo interpretation is a long-standing technique that has been used to study landscapes, identify objects, and extract information from aerial photographs. The process of air photo interpretation is one of learning to associate the visual characteristics on air photos with real objects on the ground. Visual characteristics can include context, tone, shape, pattern, and texture. Air photo interpretation was initially used during wartime efforts for reconnaissance surveys In fact, during World War II, the chief of the German General Staff stated, quote, that the nation with the best photo reconnaissance will win the war, end quote. Initially, Germany led the world in photo reconnaissance, but by 1945, the United States had the best photo interpretation capacity of any nation in the world. After World War II, aerial photography and mapping methods continued to advance. For instance, color infrared aerial photography became an important element in identifying different vegetation types and detecting disease and damaged vegetation. Accordingly, air photo interpretation was extensively used in farmland and forest inventories. During the 1970s and 1980s, air photo interpretation techniques became the foundation for the first generation of land cover maps and detailed wetland inventories in the United States. In 1975, the United States Geological Survey began producing nationally consistent land use and land cover maps. The numerically coded black and white image is an actual land cover map for a part of Lebanon, Missouri. These maps were later converted to ARC info files in the 1990s and enhanced for use in GIS. In 1979, the National Wetlands Inventory was initiated by the United States Fish and Wildlife Service to produce detailed wetland maps for management and statistical reporting purposes. By 2001, which was more than 2 decades later, the inventory had produced draft or final maps for roughly 90% of the lower 48 states. In both instances, a variety of black and white and color infrared aerial photographs were used. 2 common mapping sources were aerial photographs from the National High Altitude Photography Program, or NHAP, and aerial photographs from the National Aerial Photography Program, or NAP. While manual air photo interpretation has proven to be highly effective and accurate, it is extremely time-consuming, labor-intensive, and cost-prohibitive. This is evidenced by the length of time that it took to complete these 2 nationwide mapping projects. So in the 1970s, while many nationwide data sets were starting to be developed using manual methods, Earth observation satellites, specifically Landsat, began acquiring images of the entire Earth with the primary goal of providing data about the Earth's natural resources. As the availability of these digital images increased over time, the demand for improved and semi-automated land cover mapping methods grew. Accordingly, pixel-based image classifiers were developed to produce land cover and land use data from these digital satellite images. In pixel-based image classification, individual image pixels are classified based on the spectral information contained within the bands or channels. Therefore, each pixel is assigned to just one class. Pixel-based classifiers have become the traditional approach to satellite image classification, and over the years, several sophisticated algorithms have been implemented to develop national and regional data sets, including the National Land Cover Database and Landfire data. So while pixel-based classifiers have been extremely valuable in conducting global, national, and regional studies, they are not suited for fine scales or high-resolution imagery. When traditional pixel-based approaches are applied to high-resolution imagery, the output is frequently a less accurate and pixelated representation that exhibits what is called the salt and pepper effect. This is because single pixels no longer capture the characteristics of entire features. This is shown in the comparison between the 30-meter Landsat image and the 1-meter NAPE image. In other words, pixels in medium resolution images may represent just one feature, but in contrast, one feature such as a building may be composed of multiple pixels in high resolution imagery. Thus, the increased variability within high resolution imagery confuses the pixel-based classifiers and often results in error. In the examples to the right, pixel-based classifiers were applied to high resolution imagery to develop land cover data. As you can see, the outputs appear to be pixelated or speckled. The error or confusion is particularly evident in the lower example. The limitations associated with air photo interpretation and pixel-based classifiers prompted scientists to develop a new mapping method called object-based image analysis. Object-based image analysis uses a combination of both geospatial and image processing concepts to extract land cover data from high-resolution imagery. The primary objective of this approach is to replicate human interpretation of images in semi-automated ways that result in increased repeatability and decreased subjectivity and expense. Object-based image analysis accounts for many of the visual cues that humans rely on in manual air photo interpretation, including spectral, spatial, textural, and contextual information. The foundational process of object-based image analysis is segmentation. Segmentation, as the term suggests, segments or partitions an image into image objects, much like a jigsaw puzzle. The process aggregates the high level of detail contained within high-resolution imagery and converts units of analysis from pixels to image objects. So when object-based image analysis is applied to the high-resolution aerial images shown in the previous slide, the land cover classifications become strikingly improved. Land cover types are more defined, and there is less variability and error within each class. The object-based image analysis software package that the RSGS lab uses for high-resolution land cover mapping is Trimble eCognition. eCognition has become the leading object-based image analysis software because it integrates imagery and a variety of other geospatial data sets. It also provides an iterative yet structured workflow that entails data integration, image segmentation, rule set development, and image classification. To provide you with a general idea of how eCognition works, I've created this basic example. I opened this photo that I took at Coral Pink Sand Dunes State Park in southern Utah. This is a typical digital photo that is composed of red, green, and blue channels. Each channel or band captures a different portion of the electromagnetic spectrum. For example, the red channel shows reflected red light. Therefore, in this image, the sand is brighter in the red channel because it is reflecting more red light. By using one of the segmentation algorithms in eCognition, the image is segmented into objects based on spectral values. The goal of this particular algorithm is to group pixels in order to minimize the spectral variation that can often lead to error or confusion. In order to create more meaningful image objects, another segmentation algorithm can be applied. So with meaningful image objects defined, classes can be identified. After classes have been identified, a set of rules can be developed to classify the image. And in this example, a few rules were developed to classify the four main features in the digital image, including the flowers, the sand, the sky, and the vegetation. Okay, so with that brief overview of land cover mapping methods, I will now get into the meat of the presentation. I'll be talking about the three projects of interest. So I'll first talk about a mapping project that was funded by the EPA to support Utah's wetland program plan and watershed planning and management. Second, I will talk about the Price River riparian vegetation mapping project. This project was funded by multiple agencies, involved several partners, and was conducted to support riparian and aquatic habitat restoration. Lastly, I will talk about the Water Maps program at Utah State University and how high-resolution urban land cover data sets have been developed and used to support urban landscape water conservation. In this first project, a high-resolution land cover data set was developed with a specific focus on mapping and quantifying impervious surfaces. Through an EPA wetland program development grant, the RSGS lab partnered with Utah Division of Water Quality and the Utah Geological Survey to create a data set that could be used to support wetland restoration and conservation and watershed condition assessments. The Utah Division of Water Quality and the Utah Geological Survey developed Utah's wetland program plan. Both state agencies, believed that a high resolution impervious surface data set could be integrated into the Great Salt Lake wetland planning as well as watershed planning, because impervious surfaces can often have significant impacts on water quality and aquatic environments. Land cover data were developed for 3 watershed subbasins that encompass the urbanized Wasatch Front and are within close proximity to the Great Salt Lake wetlands. The 3 watershed subbasins of interest include the Lower Bear Malad, Lower Weber, and Jordan. For this project, I used 4-band 1-meter NAPE aerial imagery that was acquired in 2011. By using the red and near infrared bands from the imagery, a normalized difference vegetation index was generated to support the classification. Elevation data were also integrated into the e-cognition rule set to help limit the analysis of urban areas to the valleys of the Wasatch Front and back. Lastly, I decided to incorporate some vector data sets to help improve the overall accuracy of the classification. Vector data sets, including water-related land use data, road centerline data, and soils data, were used to create a series of nested classification areas. By having nested classification areas, common misclassification errors can be minimized. For instance, the urban polygons within the water-related land use data are most likely to be urban areas on the ground. Therefore, object-based rules for those areas can strictly focus on urban land cover types. The integration of vector data actually became an important step because impervious surfaces are often confused with barren lands, fallow agricultural fields, or playas due to the similarity in brightness values. This project took a total of 3 years to complete due to the size of the study area, the scale of the data, and the need to conduct some manual editing. Since the spatial resolution of the 2011 NAPE imagery is 1 meter, the spatial resolution of the land cover data is also 1 meter. The final classification included 9 different land cover classes. However, because one of the primary objectives of this project was to evaluate impervious surfaces by watershed subbasin, a binary classification was created to depict the presence and absence of impervious surfaces. The topic of impervious surfaces remains a priority of natural resource managers and urban planners because impervious cover effectively seals surfaces and prevents precipitation and runoff from infiltrating soils. Therefore, as impervious cover increases, infiltration decreases and runoff increases. With an increase in runoff, a variety of hydrologic and chemical changes can occur within a watershed. For instance, water chemistry and quality are impacted because urban and industrial development often generate more pollutants. The impervious cover model on the right shows the average percentages of impervious cover at which water quality and watershed function begins to decline. This model, as well as the majority of the literature, suggests that adverse changes occur when impervious cover within a watershed exceeds 10%. The impervious cover model can be used in conjunction with the impervious surface land cover data to evaluate the general health of subwatersheds within the 3 subbasins. Therefore, the total area of impervious cover within each subwatershed was calculated, and each subwatershed was assigned to one of the impervious cover model classes. In the figure to the right, subwatersheds with greater than 5% impervious cover are labeled. As you can see, there are several subwatersheds in the Jordan subbasin that are classified as non-supporting. This area corresponds to the highly urbanized area within the Salt Lake Valley. This output provides state agencies and land managers with important information that can be used to support restoration efforts and mitigation measures. While impervious surface land cover data can be used as an indicator of watershed or subwatershed condition, it can also be used by land managers in a number of other ways. At coarser scales, such as a subbasin or county, impervious surface data can be used as an overall index of growth and intensity. At finer scales, such as a municipal or parcel level, it can be used to support more sustainable land use policies and stormwater assessments. In fact, when I was working on this project, the city of West Jordan City contacted the RSGS lab to do a more detailed classification for their city area to support stormwater management. The image on the right shows just another way the data can be used. In this example, the percent impervious cover by parcel was calculated for the northern portion of Salt Lake City. This simple analysis can quickly identify where urban runoff may be more prevalent. Okay, so let's go on to the second project. In the second project, a high resolution riparian land cover data set was developed for the lower reaches of the Price River riparian corridor from Wellington, Utah to the confluence of the Green River. Within the study area, there are roughly 93 miles of river. This project was funded by the United States Geological Survey, the Utah Division of Wildlife, and the Bureau of Land Management. These agencies had determined that a high resolution land cover data set would be a necessary and supporting element of a restoration plan. Restoration of the Price River has been a focus of agency efforts because it has been impacted by invasive species, dewatering, overgrazing, and sedimentation. Invasive species such as tamarisk present one of the greatest threats to the riparian ecosystem. Tamarisk has narrowed the river channel, displaced native vegetation, and reduced the quality of aquatic and terrestrial habitat. As a result, the populations of several native fish species have declined. For this project, the 2014 NAEP aerial imagery served as the foundation for the classification. As with the previous project, a few vector data sets were integrated into the model to be used as nested classification areas. The image on the left shows in more detail as to how vector data can be used in e-cognition. In this example, the major rivers polygon data from the National Hydrography Dataset was imported into e-cognition, and various rules were defined to create a more accurate representation of the river. This project involved a significant amount of fieldwork, and during fieldwork, 12 mapping classes were identified. Of particular importance were tamarisk, Russian olive, cottonwood trees, and willow and Phragmites communities. This image shows the zoomed out extent of part of the classification. It shows a portion of the Price River that is located south of Highway 191 and northwest of Woodside, Utah. As you can see, the distribution of the riparian vegetation is constrained by their surrounding topography. There are some small agricultural parcels in the former floodplain of the river. This data set was incorporated into the Price River Restoration and Monitoring Plan that was completed just last year. The Price River project was probably one of the most interesting projects that I've worked on. Therefore, I decided to pursue additional funding to do some more research. Through a grant from the USGS funded America View program, I decided to build upon the previous work and evaluate the historic river conditions of the Price River. In order to do this, I worked with historic ground and oblique photographs of the area. I spent some time at the Utah State Historical Society searching their archives for historic photos of the area. I also located a number of different historic aerial photographs for the area to conduct some basic land cover and channel morphology analyses. For those of you that are interested in looking for historic aerial photographs, there are a few different sources that I came across to support this study. The USGS has maintained an extensive collection of historic aerial photographs. The aerial photography single frame records collection includes over 6.5 million frames of digitized aerial photographs that were acquired by federal organizations from 1937 to present. For Utah-specific aerial photographs, the Utah Geological Survey and the Utah AGRC are some great resources. The Utah Geological Survey database contains over 230 different data sets, which consist of over 110,000 individual photographs. The digitized images from the USGS and Utah Geological Survey are not geo-referenced, but the Utah AGRC has done the work for some historic soil conservation service photo maps and BLM color and infrared digital ortho photos. For this study, I evaluated the Price River for 5 different years, spanning from 1938 to 2014. The 1938 aerial photographs were downloaded from the Utah Geological Survey. These images were collected under the direction of the Soil Conservation Service as part of an Upper Colorado River and Green River regional inventory. A total of 120 images were downloaded to span the study area. The images were organized by date of acquisition, opened up in Photoshop to remove the color and color information, and then stitched together to create 10 seamless mosaics. Each mosaic was then imported into ArcMap for georeferencing. The final georeference mosaic is shown on the right. The aerial photographs and imagery for the remaining 4 years were downloaded from the Utah AGRC. Fortunately, the difficult work of georeferencing had already been done for these years. I should note that I also located some historic aerial photographs of the area from the 1950s, but complete coverage of the study area was limited and scales between different collection programs were different. After I georeferenced the 1938 aerial photographs, I created a basic land cover classification for a portion of the study area. I then compared it to the 2014 classification. With the other imagery, I assessed some basic measures of river morphology, including river sinuosity and channel width. These basic assessments indicated that the Price River riparian corridor has undergone substantial changes between 1938 and 2014. Land cover calculations include a significant increase in total riparian cover from 1938 to 2014. In 1938, the riparian vegetation was patchy and dispersed and comprised of native communities. By 2014, the total riparian land cover increased and was primarily composed of tamarisk. The average channel width decreased from an average width of 149 feet or 45 meters in 1938 to just 25 feet or 8 meters in 2014. Overall, the Price River was historically a wide, shallow, and meandering river with very little vegetation on the banks. However, now it is presently a narrow in size and sediment-filled channel dominated by tamarisk. This is very unfortunate, but once again, it supports the need for monitoring and restoration. Okay, so in this last project, high resolution urban land cover data have been and are currently being developed to support water maps analyses. Dr. Joanna Interwada in the Department of Environment and Society at Utah State University leads the water maps program and team. The program is run through the Center for Water Efficient Landscape and is partially funded by Utah State University Extension. Water Maps is a custom water demand management tool that is being used to promote and guide urban landscape water conservation. Urban landscape water conservation is often an important management goal for local governments because landscape irrigation is the largest use of residential culinary water during the summer months. To help city governments identify where urban water conservation may be improved, water maps analyses can be conducted. The water maps tool integrates land cover data, water meter data, and weather data to identify parcels that may have the capacity to conserve water. Our current partners are the Salt Lake City Department of Public Utilities and Eagle Mountain City. The primary goal of water maps land cover classifications is to create detailed urban land cover data at a parcel level that can provide valuable information about the composition, distribution, and area of different land cover types. NAEP imagery serves as the basis for the land cover classifications, and since water maps has been an ongoing project, we've used multiple years of NAEP imagery. For instance, residential landscape assessments for Eagle Mountain have been conducted for 2014, 2016, and now 2018. The basic foundation for the development of water maps land cover classifications is very similar to the first project that I discussed. However, I've also integrated LiDAR data and building footprint data into the models. LiDAR data is used to develop normalized digital surface models. These models depict the height of features relative to the ground and allow differentiation between taller vegetation types, such as trees, from ground-based vegetation, such as grass. The building footprint data is used just as other vector data sets were used in previous projects. And then lastly, parcel boundaries, which are provided by our current partners, are used to focus in on the parcels of interest, whether it be residential parcels or city-owned parks or commercial properties. The urban land cover classes for water maps analyses are somewhat limited by the aerial imagery. Since NAEP imagery includes only 4 bands, there is difficulty in identifying specific vegetation types. So for now, there are some general classes, including agriculture, barren, grass or turf, impervious, riparian, sparse vegetation, trees, shrubs, and water. While most of the classes are fairly straightforward, I will comment on a few of them. In terms of agriculture, there are some remaining agricultural parcels within Salt Lake City and Eagle Mountain. This class is not used very often, but there are some instances where an agricultural plot is located near or within a parcel of interest. Barren lands include those that are completely devoid of vegetation. These can include dirt roads, gravel pits, or even elements of residential hardscapes. In water maps analyses, the most common barren areas are those in subdivisions where the land has been cleared and leveled for new construction. This is very common in newer cities such as Eagle Mountain. Sparse vegetation is another class that needs some clarification. It refers to those areas where there is minimal or senescent vegetation. It can include xeriscaped yards, vegetable or flower gardens, and perhaps yards that have minimal landscaping or that have not been maintained. As we continue to work on these projects, we are improving upon the number of classes and their definitions as imagery and vector data permit. Since the unit of analysis for water maps assessment is individual parcel, a significant amount of time is allocated to cleaning up classification errors. For example, the narrow or small features such as sidewalks may not be classified correctly, or the perimeters of structures may have some errors. Tree and building shadows often introduce error as well. Editing procedures and e-cognition allow these issues to be corrected. Therefore, the overall accuracy at the parcel level is improved. A higher level of accuracy in the land cover classification will clearly produce better quality water maps results. After manual editing has been completed, an accurate high resolution land cover data set is exported. It can then be used as an integral input in water maps analyses. As previously noted, these land cover data can provide valuable information about the composition, distribution, and area of different land cover types. Each of the irrigated land cover classes, including grass and turf, trees and shrubs, and sparse vegetation, are assigned a plant value based on estimated water use. For instance, grass is assigned a higher plant value because it clearly uses more water than, say, shrubs in a xeriscaped yard. The land cover classification is just one of the inputs in a water maps analysis. Parcel data are used to limit the analysis to each parcel. And in this instance, we are looking at parcels in a single family residential neighborhood. Water meter data are integrated into the model to provide an estimate of summer outdoor water usage. In general, these estimates are calculated by subtracting the average winter water use from the summer water use. Weather data, specifically reference evapotranspiration values, are used as an input to help determine landscape water need for certain time frames within the summer months. These 4 inputs are integrated into one model to calculate and geographically display a measurement called a landscape irrigation ratio. Landscape irrigation ratios are calculated from estimated landscape water use and estimated landscape water need. Landscape water need is derived from the water meter data, and the landscape water need is derived from the land cover data and the localized reference evapotranspiration data. Landscape irrigation ratios can indicate which landscapes are potentially being overwatered and thus identify where the greatest capacity to conserve exists. In this example, landscape irrigation ratios less than 1 are considered very efficient and suggest that the residential landowner is applying an appropriate amount of water to maintain the landscape. In parcels where the landscape irrigation ratios are greater than 3, it is suspected that the water is being used inefficiently. While these values are estimates and they can be influenced by a number of variables such as abrupt changes in household size, they can provide a good starting point for assessing where water can be conserved and where possible outreach and educational events may be valuable. So I will close on that final note. I know that was a lot of information in one presentation, but hopefully you found some of it interesting. I know that there's probably a wide variety of interests in this audience. So I was trying to, get information from a variety of projects that I've worked on. So thank you for your time. I'm happy to answer any questions or comments if there's time. Otherwise, you can contact me via email at ellie.mcginty@usu.edu.
Thanks, Ellie. That was great. Does anybody have questions? We'll give you just a second to chime in if you have a question. Well, it looked like really interesting stuff to me. So that's really great. So thank you so much for preparing that and taking the time to present today. Oh, we do have a question. Is the water maps land cover data set published?
No, so the data are strictly to be used by our partners. Joanna, the water maps director, she's published quite a few papers on water maps. But I can get some more information if you guys are interested. In contrast, like the impervious surface data, because it is a publicly available data set, that one is available to the public, but the water maps classifications are strictly used by our partners.
Awesome. So you said the impervious stuff is available publicly?
Yeah, I don't think we have it. at one point, I think we had uploaded it to the RSGS web lab site, but let me know if anyone's interested. It is a little out of date at this point because it used 2011 NAEP, but it's still a great resource if anyone is interested in it.
We have another one from Eric Neiman. Maybe I missed this, but what classification algorithms did you use in the studies?
So in the beginning, I was talking about the different mapping methods. So I used object-based image analysis, and we used Trimble eCognition to create the classifications.
Awesome. And then were they supervised?
So you can do supervised classifications in object-based image analysis software programs, but I choose to create customized rule sets. If you don't really think of object-based image analysis the same way that you would with pixel-based, because in pixel-based you have supervised and unsupervised classifications, but object-based image analysis is a whole different ballgame. While eCognition does allow you to do some create training data and execute supervised classifications, it's really not the same as, say, some of the methods in Erdas Imagine. So I create customized rule sets. And if you think of it simply, it's just a series of logic statements. So like, if this feature on the ground has these characteristics, whether they're spatial, spectral, or textural, then it is more likely to be this class. So it's a series of if-then statements.
Awesome. So there are a couple more questions. I'm wondering if we can maybe, Ellie, would you mind trying to address some of those in the chat while
Yes,
we move on to our next?
Yeah, no problem.
Okay, let's do that. I want to make sure that Haley's got plenty of time for her presentation. So thank you again, Ellie. We certainly appreciate it. And then if you don't mind responding in the chat, that would be awesome.
Okay, sounds good. Thank you.
Thank you. All right, before we move to Haley, Zlatko, do you have your humor segment ready to go? Okay, we'll let Zlatko do his little humor segment. I see your face flashing, which means you're doing something.
Can you hear that okay? Can you hear the sound?
Yeah, we can hear the sound.
Okay. All right, Chandler, do something. Come on, do something.
I am. I'm ignoring you.
Okay, here. I'm going to be the on-camera guy. All right. First stop, Westminster Abbey.
Oh, what the hell is that?
That's London, baby. All right. The hotel's here. Wait. No, we want to go. No. I know. I'm going to have to go into the map.
Okay, if you see a little version of me in there, kill it.
I got it. Here we go.
Okay, listen, we're not gonna have to walk this way the entire time, are we?
Man, you made me lose it.
Okay, that's all I had.
Awesome. Thanks, Latko. There's a debate in my family, you know, I'm trying to teach my kids how to read maps, right? And one of them is totally getting into it and the other one's like, I don't know how to do this. So I love the paper map stuff. All right, Haley Miller from Esri is with us here. She is gonna do an update on the ArcGIS solution configurable templates. Is that right, Haley?
That is right. Yep.
Awesome.
Perfect.
Thank you for being here. We appreciate it.
Yeah, no problem.
Take it
Happy to be
away.
here. Cool. I'm gonna go ahead and share my screen. Right. And hopefully you can see that. Cool.
Yep, we got it.
All right, sweet. So I will start off with just introducing myself. I know a lot of people on this call, but I don't think I know everyone. So my name's Haley Miller. I'm a solution engineer at Esri, out of the Esri Denver office, although we're working from home. And I specifically support local and regional government in Utah. So I get to work with a lot of you at the cities and the counties and the regional agencies and all of that good stuff. There's probably a big block in front of my screen. There we go. And just a quick plug for UGIC. I am planning on being there along with one of our other solution engineers, and then Ishmael Shabite. He is our product manager for Survey 123 and Quick Capture and some of our mobile tools. And so the three of us will be there. We're going to be doing some pre-conference workshops. I don't know if I'll get all of the topics right offhand, but I know there's an enterprise workshop. We have an online an ArcGIS Hub workshop, ArcGIS Pro, I'll be doing that one. And then some stuff on those mobile tools and Survey 123 as well, along with a couple of presentations throughout the week. So we are super excited. I have been supporting Utah for basically since right before COVID now, and y'all are like the coolest state and user groups to support. So everybody on my team was like really jealous when I got assigned to Utah. So thank you all for being awesome. I've never been to UGIC before. I'm really excited. So fingers crossed we can all make it out there. So I am going to just be talking about some updates to our ArcGIS solutions. These are those configurable templates. Esri's really taken a turn in the past few years and wanted to focus more on producing some configurable templates that really follow workflows that we see our customers using really frequently. And so you can always go in and configure and customize these to your needs, but it's a really useful starting point for finding workflows that might be relevant to your organization. And one thing just to note is we actually have a solutions team that develops these solutions, and they work directly with the people that are using them. And so these are really coming from the users. So if they aren't applicable to you, or if there's maybe one missing, like let us know, let Esri know, because we are always open to working on other workflows and things that would be more applicable to the people that are going to be using them. And so give us that feedback. We love to hear that. But I'm going to jump in and just start with, hopefully you can see the solutions page right here. So this is just at solutions.arcgis.com. There's been an update to this page in the past year. I don't know time lately, but I think it's been about a year or so. So the page does look a little different. So I'm just going to navigate through this really quickly so you can get familiar with that. So when we come into the solutions page, we have some information about the solutions if I scroll down, but I'm going to first start with this resources tab. This resources tab is going to be really useful for finding some learning and discovery paths. So, oh no. I can just go back to that. Oh, there we go. All right, so if we go into this resources, We're gonna have these discovery paths, and what these are is these are actual exercises from learn.arcgis.com that will actually walk you through configuring some of the solution templates that are out there. We don't have paths for every solution out there, but I think it's really helpful for getting used to kind of how to configure your solutions, how to bring in your own data, what the schema's like, and things like that. If you're just getting started with solutions, or if there's a specific solution you're interested in, I would definitely search in this bar here and see if there is a path that can kind of walk you through configuring that. There's some other documentation, some blogs, blog articles, and things like that, and some videos as well. Specifically, this ArcGIS Solutions for Government meetups. This is a playlist on YouTube where our solutions team actually dives into a different solution for each meetup, and they walk through actually configuring and using those solutions. So that also has some really, really good content and resources. And then back in the overview page where we started, I'm going to go ahead and scroll down here, and we have these different industries. So this is how we organize our different solutions and templates. And so you can go ahead and select an industry that you're interested in. I'll go ahead and do state and local government since that's what I work with mostly. I don't know why it wants to log me out. All right. And so once we get into the sector, then it's also broken down even further from there. So when we're looking at state and local government, we have agriculture, assessment and taxation, elections, emergency management, fire service, tons and tons of different, even more specific kind of sectors. And then if we wanted to dive into one, let's say public works, for example, then we're going to see those actual solution templates. And so as we scroll down here, we're going to see tons for public works. This is a suite of solutions. So if we jumped into, capital project tracking, for example, now we're going to get information on that specific solution. And oftentimes one solution can have many different components. So it can include mobile apps, it can include dashboards, it can include a hub site, and lots of things like that. And so once we dive into that specific solution, we can get more on, okay, what items are going to be included with this solution when I deploy it. Before I go ahead and show you how to deploy a solution, I just want to show you for each solution kind of package, we have these two tabs, so a use and a configure. This use tab is going to often have some examples of what apps, kind of what the end result of these apps are, and it's going to teach you how to actually navigate through that app. So if I went ahead and opened up this capital project reports app, I can actually see what that app is going to look like when there's some data in it and things like that with some demo information. I'm sorry, my Wi-Fi is moving slow today. I was on vacation last week, so my computer was as well. Still coming back. But yeah, we can go ahead and actually view and interact with that solution, so we can kind of see what we like about it, or maybe what we don't like, and things like that. And then the other tab is going to be the configure, and this is going to be really important as you are going in and actually deploying a solution, because this is going to go through step by step how to load your data, how to do the field matching, and how to actually launch these different apps and items and feature layers and things like that for your organization specifically. So this is really useful for going step by step and actually making these solutions come to life. So with that, I am just going to dive into the damage assessment solution specifically, because we recently have done a pretty huge update to this solution. And one thing that our solutions team is doing is, apart from just creating more new solution templates for new workflows and things like that is they're going back and they're refreshing and updating some of the solutions that have existed. So maybe you've deployed solutions in the past, but there might be some new components and things to those solutions that you can now add on and make it even more end-to-end. The other thing is these updates to these solutions are including some of our most up-to-date technology. And so we have things which I'll show you like hub sites and experience builder applications and things like that embedded so that these solutions are going to be more mobile friendly and using some of the capabilities that are newer to the technology in general. So it's definitely worth checking it out and kind of seeing, you know, when some of these solutions have been less updated and trying to stay more up to date on those. So diving into the damage assessment solution, I'm just going to show you some aspects of this solution, but I'm not going to show the mobile app tools, but there are some quick capture and survey 1, 2, 3 components as well. So what we see here is a hub site. So a lot of these solutions now exist on hub site templates. So this is the damage assessment hub template. And really what this is Hub was previously open data, but it's become more initiative focused. So you can create as many sites as you'd like. With ArcGIS Online, you have access to Hub Basic. And so you're able to create these sites often focused around a specific initiative or a department. And they serve as sort of a like landing page for apps, maps, data, and text. You can also include data that isn't GIS, like doesn't have to be a shapefile or a geodatabase. We can put CSVs and PDFs and things like that in there as well. So it's a really good destination page for either the public or for internal users in your organization to visit to get some information that they may need. So when we are looking at the damage assessment hub site, what you'll notice first is that we have scrolling text at the top that might be giving critical information on a current situation. So we have an advisory issue. It's a little bit outdated. So, oh, it didn't happen yet, actually. That gives you some information of maybe the public of what they need to be aware of. Then as we scroll down, we get some information about damage assessments, what's been completed, or how many properties are destroyed or damaged. All of this data is coming directly from our feature layers in ArcGIS Online. So as more damage or assessments are completed, this will update interactively in near real time. So you don't have to go in and manually change these numbers. That's going to be linked to the data that is being updated. So for the damage reports, first we have this review conditions button right here. So I'm going to go ahead and select this. And then this is going to be using a configurable application called the attachment viewer so that we can view any photos of damage that has been reported. You'll notice in this pop-up too, there's a self-report button as well, so that for the general public, if I needed to report my damage, I can go ahead and do that. And I will show that in just a little bit. I'm going to go ahead and explore these damaged photos. So in the map here, we see different points and things of where there has been damage reported, symbolized by how severe the damage is. And so we can go ahead and dive into some of these photos to see some more information about this damage. So as I select this photo, I can see the point where this photo was captured. I can actually zoom in to that point as well to get more details. I've seen people use imagery-based maps for this as well to get even more information about that location. And we have the date that it was captured and reported, and then the damage level here. And then I can go ahead and make this full screen and zoom into this photo as well, so I can get even more information by panning and zooming and all of that good stuff. I can also tweet this application out. So maybe I want other people in my area to know that this is a resource if something happened recently. I can go ahead and just click this little tweet button and a link to this app. I could obviously change this text would show up, and I can go ahead and tweet that out so that other people can have access to that as well. So going back, we also have the report damage tool. So we saw there was a button in the pop-up when I went to view the damage, but we also can go ahead and fill out a survey to report our own damage. And so this exists on survey 123. Again, this survey is configurable, so you can change the questions and things like that. But we can go ahead and give some information on what damage has taken place. I'll go in and zoom in somewhere in Denver and drop a point. And then some of these will autofill based on where I just dropped that point. So we have some reverse geocoding happening here. I'll go ahead and select it. Fill out.
Will it go the other way? Will it geocode if you put the address in and drop the point on the place?
Yes, it will. Actually, so if you put the address in through here, it will. If you fill the address in down here, I don't believe so. That's a great question. However, so what you can do is you can have it geocode in the background. So we see some surveys where it doesn't even have the map. And to be honest, sometimes we see that non-GIS users seeing this map get a little overwhelmed or confused on how to drop a point. I know for all of that, like we do this all the time, but sometimes users that aren't working in these contexts would rather just type in an address. So sometimes we just remove the map altogether. There also has been a recent update to Survey 123 actually, where you can type in the address and then you can confirm it on that map. So yeah, it will go the other way. Take that back. Now I can give some information on the structure type, maybe I'm a renter and do I have insurance? And then give some more information. I'll type in my name. And my email. And say yes. And now I can give some information on what caused the damage, if I was displaced from my home or lost transportation, what specifically was damaged. And there's lots of other information that I can add in here. And then I can go ahead and upload any photos, as many photos as I'd like. And all of these photos will be stored in a related table to that point that I dropped so that we can go ahead and link those to the point and the information. And then I don't have any photos, so I'm not going to go ahead and submit this. But once I did press submit, then it's going to show up right within this photo viewer. All right, I'm going to go back to the hub site now. All right, so then we have room to add any other text or information. With Hub Premium, you also have the ability to add events. Maybe if there's a public hearing or something like that, you can post these here, Zoom links and all of that good stuff, and some contact information at the bottom. The next thing that I want to show is that we have this little internal destination tab right here. So there's a few different ways that we can use this. We can create a page on our hub site that is only accessible to the organization and ArcGIS Online itself. We can also, if we have Hub Premium, we can create and leverage what we call community users, where other people can create their own ArcGIS Online kind of logins. They can link it to Gmail or Facebook or something like that, and then request access to a more internal page. We often see this used for other kind of community organizations or nonprofits or volunteers or things like that, if they need to get access to data as well, but we maybe don't want it to be out there for the general public. So if I jump into this internal destination tab right here, now we're going to get some other apps and maps that are included in the solution as well, with some other information. So what I'm seeing right here is a dashboard that we can explore to see all of the different damage that has been reported, whether it was by our organization's field workers and collected out there or from the public as well. And we can get some information on those points, and we can do a lot of filtering and things like that, which I will do shortly. We also, if you continue to scroll down, as we have some options for, let's say that this is the internal page for volunteers or things like that, we have some QR codes that they can pull up that survey form or a quick capture form right from their computers. So if you have quick capture on your phone right now, you could go ahead and scan this QR code, and it's going to open up a template for reporting windshield damage. And so you could go ahead, open that up, and then it can capture your location. And that's going to be a big button, quick capture template. So you really just have to press a button and take a photo, and that will automatically submit that information. So it's pretty quick to report, and only a couple buttons really that you have to press. And so coming to this page and then being able to open that up right when you're out in the field or things like that, just really streamlines the workflow for the people out in the field that are collecting this information. We also have some information on what the different categories of damage are. So what is affected, minor, major, or completely destroyed, some things like that. We continue to scroll. We then included a couple more QR codes for individual assistance surveys and public assistance surveys as well. Again, you could open up your phone right now and launch these surveys and fill out a report. So really the idea here is to make it quick and easy and accessible to people out in the field or at their computers or wherever they are, to report some of this damage and things like that. The third thing that I want to show that's included in this solution is a configuration of ArcGIS Experience Builder. And so Experience Builder is a relatively newer tool in ArcGIS Online, and it can be used in a lot of different ways. And so it's hard to kind of create a one-line statement of what Experience Builder is. But what's really great about it is that you can customize it. You can customize it to really like switch off based on what people are viewing things on. So for example, if you just had a dashboard and you want somebody to be able to view that on a mobile device, if any of you have made dashboards in the past and then tried to open them up on the mobile device, sometimes things are like kind of like crammed and layered and things like that. You can completely configure what this page is going to look like on a tablet versus a mobile device versus a smaller screen. So if I went ahead and actually made this smaller, well, what we're looking at isn't that cool, but it will actually change depending on the screen that I'm looking at it on. So if we didn't have it set up for a mobile device, which I guess in this case for this home page we don't, and it will just tell you that as well. But that's a huge benefit to Experience Builder. So I definitely recommend checking that out if you haven't. And if you have dashboards, hosting them in Experience Builder can really make your life and the end user's life a lot easier. So in this Experience Builder template, we have a couple different tools here. So first we have this Manage tool. So when we go ahead and click this tab, again, we're just going to get some data, some kind of key indicators that show up here. But we also have a drop down, so we can open up Managing Damage Reports. And so currently what we see right here is we have the different damage reports that have been created. And so this is going to be for the person back at the office that can now see what reports are coming in and then assign those to different individuals to actually go, on site and deal with whatever the damage or the report is. So right away, we have some individual assistance and some public assistance reports. And if I open up these individual assistance reports, I can see the different addresses of where these are taking place. And I can actually go in and see, where that point is, when it was last edited, if there's a damage level reported or some other information, any comments or who it was assigned to, and if there are any photos, I could go ahead and open those as well. And we can see some of these even have a couple reports, which I don't know, here we go. So maybe there were duplicates or maybe there were just multiple people reporting similar damage. And so we could go in here and actually edit that so that if we wanted to say, oh, this is actually a duplicate, we can actually report that as well as we dive in and, say, this is a duplicate, don't need, or something like that. And if I go ahead and save that, then it's going to remove that duplicate point from my data. So this is a great place for some QA/QC of the data as well. I can go ahead and also report or assign damage right from here as well. So maybe if somebody calls me on the phone and they don't have access to reporting something in the field, I could go ahead and drop a point on here and fill out that information on my own. Looks like I don't know why it said that. And add photos or things like that. The other thing that we can do from here is we can actually filter some of this data. And so right now we have all of the unassigned reports that we're looking at right now. So this helps me as the person back at the office to see what I still need to assign to people, what's coming in that people need to go take care of. So if I uncheck that, we're going to see some more points that are coming up at various stages of being dealt with and kind of that process. I can also see what was specifically assigned to someone specific out in the field. So Chris Delaney, for example, I can now filter what has he been assigned to and kind of where those locations are. And then similarly with public assistance, we can do some assignment and filtering as well. I could also filter by status, so I can see which has been completed, and now I know what I don't have to worry about, or maybe this has been dealt with and things like that. So I can get information on those as well. And so that's some information on the managing reports tool. We then have a monitoring reports tool. And so again, first, when we open this up, we're going to see some information about the data. And then we can dive into some of those apps. So we already took a look at the photo viewer and we saw the dashboard a little bit as well. But we can go in and look at this dashboard in a full screen and then do some filtering on this as well. So it really gives you an overall picture of kind of what is going on, what's been impacted, and how severe that impact has been. We can filter based on things like what is not insured, for example, and what that damage is. We can filter on the report status, so we can see which damage has been dealt with or completed. We can also do some archiving of data in the past. So maybe we want to look at what happened previously, maybe in a disaster that happened prior. And then finally, we can see the report type. So we can see what or where the data came from, whether it was like the public reporting that they found it on, through Survey 123 on the hub site, or if it was a windshield report, things like that. And as I'm clicking through these and panning through the map, all of this data is being updated at the bottom here. as well as on the right. And we can go ahead and select, and then again, just get some more information on the damage, the location, the status, and then if there were any photos or things like that. So that's the monitoring page. And then the last thing that I wanted to talk about is the administer page. And so there are a ton of new really cool things that you can do with this solution as an administrator. And so quickly, I'm just gonna go through these, but I'm not gonna actually open them up too much. So the first one is collaborating. So if we wanted to collaborate with other partners or other government agencies or things like that, this will open up actually an ArcGIS Online group where people can share maybe their data, their feature layers, their dashboards, or things like that. So we can give people access to this group to open it up to their data and things like that. We have a link here to manage active incidents. If maybe you have a whole CSV file that you need to update, you can go ahead and upload those here. And that's just going to update all of our feature layers in ArcGIS Online and then update the applications that go along with those. Provision users, so giving people access to using those mobile tools like Quick Capture or Survey 123 out in the field. So if we have that list of volunteers that's maybe going to go out and do the assessment, we can go ahead and select this, and it's going to bring us right into the settings to assign those users the tools that they need to be able to access that. Generate reports, so we can actually generate and download different reports based on the data that's in there. So if we want a snapshot of that data, we can give certain people access to be able to do that so that they can go ahead and print those out or maybe take different snapshots throughout the process of kind of dealing with the event that occurred. And then we have the export photos. So as those photos come in, we've had a lot of agencies that want to actually be able to export and save those files. And so they'll take them out and save them on a separate storage device or something like that. So we can go ahead and do kind of a mass export of the different photos that have been submitted using a notebook. And it also, in the metadata with those photos, it includes the address or the location of that photo, and then the source of that photo and either the username or things like that. And then finally, we have a notebook to actually archive different incidents. So whether you want to just create an archive and a data file that you want to save, and again, put on a separate place to store or something like that, you could go ahead and copy those, back those up, or save them. And you can also create the settings so that once you archive those, maybe you don't want those to show up in the dashboard because it's not a relevant or current event. It was a previous one. You also can use this workflow to go ahead and delete old data if that's what you'd like to do as well, and just completely, that was 10 years ago, we don't need it anymore. We want to start new kind of thing. And then finally, there is a little help tab here that actually gives you information on what each of these different tools and apps do. That's not loading too well, but and so you can get some more information on how to use the different links and apps and things right within here. So that's kind of all I have. I thought that this was a really good solution to show you how our solutions team has really been focusing on the whole end-to-end process of the workflow and making it as easy and configurable for the end user as possible. Like I said, I think we have like over 200 of these solutions. So there's solutions for so many different sectors, workflows, and things like that. And if there's one missing, please do let us know if you think there's one that would be really useful to your organization and others as well. Because we're happy to work on that with you and make sure that these are useful for all of you. The last thing that I wanted to mention is if you are looking at these solutions, or if you already have deployed solutions in the past and you ever need support or things like that, I, as a solution engineer, can walk you through configuring these and things like that for no cost to you. We're always happy to help that out, as well as any other solution engineers or technical people that you have access to at Esri. Really, these were designed to be hopefully easy to use for the end user, and so we're happy to help out with that. And the other thing is, you can always purchase Esri's professional services to go in and implement these for you in your organization as well. And so that's an option for you as well if you just want these up and running so that your team can go ahead and start using them. That is, of course, an option too. But that is all I got. I see a question come in, so I'll open it up to questions for others, and I'll let me read that one as well. Is there any advantage to use dashboards natively versus hosted within Experience Builder, or would all dashboards be better off within Experience Builder? Great question, Adrian. So I would still say, you know, dashboards is its own application and has some really cool benefits. So what I see a lot of users doing is creating a dashboard just within ArcGIS dashboards, and then embedding that dashboard into Experience Builder. But if you go in and edit that dashboard and things, you would do that through the dashboards experience. And the reason being is just dashboards was configured initially as like a browser-based tool. And so it wasn't created to be as mobile friendly. But we're able to then create some more mobile friendly versions of that dashboard using Experience Builder. But I would still start with ArcGIS dashboards. If you're going for the kind of monitoring data tool, that this is a really good place to start. And then, so I can actually show, I think that this one might have a, maybe it doesn't, we'll see, a mobile, maybe not a mobile interface, but it looks like this one does not. Is Experience Builder kind of like a replacement for Web App Builder? That's a really good question as well. I would say it is, and it isn't. And what I mean by that is the Web App Builder really has kind of like a one-size-fits-all interface. And so you can add the certain widgets. And some people are really comfortable with that, and they've created their own widgets, and they just want a map-first experience with a few different widgets to do, you know, one or two things with a certain data set. And for that reason, you know, go ahead and continue to use Web App Builder. When it comes to Experience Builder, I think it's more of like an entire site that is all integrated and interactive. And so there's a lot more that you can do with it, but it also is a lot more complex. And so if you want just that map first experience with a couple tools, go with Web App Builder. If you want a really like more seamless, interactive with lots of different tabs, and you want to be able to click text that's going to then filter a map and do a lot of different things, then I would definitely check out the Experience Builder route.
Awesome. Thank you so much, Haley. We are mostly out of time. We maybe have one more question if there's one more question out there. Otherwise, we probably should wrap it up because we're bumping up against 1 o'clock. So one more question.
I'll put my email in the chat, so if anybody does have any questions, just feel free to reach out.
Awesome. Well, I want to, again, we're super grateful for Ellie and for Haley to be willing to present today. And Haley jumped in last minute, so thanks for helping us out last minute on that. One more note really quick. if you are not getting our emails and you want to reach out to one of the board members and we can make sure we get that added. There's me, Zlatko, Adrian, Rachel Manko, and Corey Meekum, and Justin Johnson. So if one of those names rings a bell and you're not getting the emails, reach out to one of us and we'll make sure you get the emails. We'll get that website up and running just as soon as we can, and we'll share that with everybody. We did record this, so once we get the website fixed and everything, we'll put this up on the website as well. Guys, did I miss anything? Okay, well then, thanks everybody for coming and have a great rest of your day.
Thanks so much.
Thanks again. See you.